Hi guys, in this question we're asked to solve this inequality. Now this could link to graphs. For example, they could say f of x is equal to 8, g of x is equal to 2 over x, and then ask you to solve something like this. Okay? Now the problem we have here is when we're multiplying, if that's positive, then that's absolutely fine. Oh, I should address this. This means x cannot equal 0 because 2 divided by 0 is undefined. But the trick is with inequalities, if you're times in by a positive, it's no big deal. But if you're times in by a negative, then the sign would change, which we can't have. So we don't know. We're not told whether this is positive or negative. So what we're actually going to do is think, how can we make sure that what we multiply by is positive, and therefore the sign doesn't need to change? Now the reason I'm doing that is this is basically an equation and we need to find out what x is, right? So if we times by x on its own, we will actually lose some solutions because we don't know whether it's positive or negative. So how can we make a positive number? Well, square numbers are always positive. So if we times this side or both sides by x squared, what you're going to end up with is this. And you should be able to see that that will cancel now. Okay, so we've now got a quadratic. In fact, I'll just write that so it looks a bit neater. We've now got a quadratic equation, but it's not ready to factorize and solve. So let's get everything on one side. I'm a bit annoyed with myself there. I've lost my nice neat line, but you get the idea. Okay, so there is something common to both terms, so let's factorize for the highest common factor. And now we're going to make our critical values. So 2x is equal to 0, so x would be 0. 4x minus 1 would be equal to 0, so x is equal to 1/4. If you need to take a few stages to get there, that's fine, but most people who are watching this video will be happy going from there to there. And these are my critical values. So I'm going to make a sketch. I've got 0, and I'm going to just put a quarter over here just to help the sketch. And I'm sketching this because, yes, I know this is a reciprocal graph, this is a linear graph, but I formed a quadratic. So I'm solving a quadratic, so I'm interested in drawing my quadratic. Now, happy quadratic, positive x squared, so it's like this. And we're looking at where this function here is greater than 0. So there's the function of x. Where is the function of x equals 0? And that's above this line. So let's get out a nice colourful pen. So we're looking at this area here and this area here. So we can say, but that was a quarter and that was 0, wasn't it? So x is greater than a quarter, put our set notation on. And x was less than 0, and add our set notation. Because it's there and there, we're going to unionize those two, find the union of both of those. Okay, so maybe you're wondering, well, what does this look like on a graph? So let's try and draw a graph. That's not the best line I've ever done, but it's good enough. Okay, so let's just say, let's make the presumption that y is a function of x. So we've got y and we've got x. So that means y is equal to 8. It's going to look something like that. Then we've got the graph 2 over x, and reciprocal graphs, they look like this. Now that's a pretty, I probably should have gone a lot closer, but that's no bother. So you can see, where is the 8? Where is this line greater than this line? It just means, where is it above? So you can see here, this line is clearly above this line. And all the way along here, it is clearly above this line. So if we try to solve these two graphs, and we have 2 over x equals 8, so then we would get 8 is a quarter. And you'll see that that's the result that we found out here as well. And you can see when x was greater than a quarter, this line was higher than this one. There's my answer here. And when x is less than 0, it worked as well. Remember, x can't be 0 because on this reciprocal graph it doesn't actually ever get to 0, it's undefined. So that's why we can't include this line. And all of this area here, you can see that it's the reciprocal graph that's actually above the other one. So let's imagine we change the question. If we had it this way round, your answer would actually be in there. Okay? So it would actually be in between these. Where is this graph lower than that graph? Okay, so hopefully that makes sense. You've just got to be really careful when you've got a denominator of x with an inequality. Just to remind you, you've got to make sure it's positive that you're times them by, so we don't have to change the inequality sign, because if we do, we'll lose the solution. Well, if you times by x and don't change it, actually that's very confusing. So just remember, you've got to times by a square number, so make it squared. It's probably worth mentioning quickly, if I had something like this, I would have to times by x minus 1 squared. Because the only way I can guarantee that that is positive is by squaring it. The denominators would go, that's what I wanted to happen, and I've got a quadratic. Actually, this one's cubic, but that's for another day.